In this episode, we're going to make contextual integrity feel practical by using it as a simple, repeatable way to judge whether a data use fits the situation people believe they are in. Many beginners can explain privacy in general terms, but they still feel unsure when a scenario is messy because real processing rarely looks like a neat diagram with clearly labeled boxes. Contextual integrity helps because it treats privacy as an expectation problem, not just a secrecy problem, and that matches how most users experience privacy in real life. When people feel surprised or betrayed, it is usually because data moved or was used in a way that didn't match the context they thought they agreed to. For the Certified Information Privacy Technologist, CIPT, exam, you don't need to sound philosophical, but you do need to recognize when a processing scenario violates expected norms and what engineering or operational moves would bring it back into alignment. By the end, you should be able to look at a scenario, describe the relevant context, and decide whether the flow fits or breaks it. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful starting point is to understand contextual integrity as a norm-based view of privacy, where the main question is whether information is flowing in a way that makes sense for that particular setting. In everyday life, you already use this logic without naming it, because you naturally behave differently in a classroom than in a doctor's office, and you expect different handling of your information in each place. Contextual integrity says that privacy is preserved when information flows follow appropriate norms for the context, and privacy is violated when information flows break those norms. This is powerful because it avoids the false idea that privacy means no sharing or that privacy means hiding everything. Instead, it recognizes that sharing can be normal and still be privacy-respecting as long as it matches the context and is done with the right constraints. For privacy technologists, this provides a structured way to evaluate processing that goes beyond whether the system is secure. It asks whether the system is appropriate. To apply contextual integrity in a disciplined way, you need a few components that help you describe what is happening without getting lost in details. Think of the context as the setting and its social purpose, like education, healthcare, banking, or social connection, because purpose shapes what flows people expect. Then identify the roles involved, such as the person the data is about, the organization collecting it, and any other parties receiving or using it. Next, identify the type of information involved, because expectations change depending on whether the data is a contact detail, a location trace, a purchase history, or something more sensitive. Finally, focus on the transmission principle, meaning the conditions under which the data is shared or used, such as for a specific purpose, for a limited time, with consent, or only with certain safeguards. You don't need these terms memorized as jargon, but you do need the habit of naming roles, data types, and conditions. This habit makes scenarios easier to reason about on an exam. Once you have that structure, the next step is to compare the expected flow with the actual flow in the scenario, because contextual integrity is all about mismatch. The expected flow is what a reasonable user would assume given the context, the product experience, and what they were told. The actual flow is what the system truly does, including behind-the-scenes sharing, secondary uses, and retention behaviors that users don't see. Many privacy failures occur when the expected flow is narrow, like using data to provide a service, but the actual flow is broader, like using the same data for unrelated targeting or extensive sharing. A beginner misunderstanding is to assume that if a notice exists somewhere, the expected flow automatically expands to match whatever the company wants. In reality, trust and fairness depend on whether people can understand and anticipate the flow in the moment, not just whether the flow is technically disclosed in dense language. When you compare expected and actual flows, you can pinpoint the exact place where integrity breaks. Consider a simple processing scenario that feels ordinary. A fitness app collects steps and heart rate to provide activity insights. In that context, most users expect the app to use those measurements to show trends, set goals, and maybe synchronize across the user's own devices. If the app starts sharing raw heart rate readings with an advertising network to infer mood and deliver targeted ads, many users would experience that as a context shift because the data was collected in a health-like setting but repurposed into a marketing setting. The issue is not that data was shared, but that the transmission principle changed from helping the user manage health to helping a third party target the user. Even if the app is secure, the integrity of the context has been violated because the use no longer matches the purpose users assumed. A privacy technologist applying contextual integrity would identify the roles, the sensitive attributes, and the changed condition of use, and then would look for ways to realign the flow. That is the kind of reasoning the exam rewards. Realignment often comes down to choosing among a few broad types of moves, and the right move depends on why the integrity broke. Sometimes the fix is minimization, meaning you stop collecting or sharing data that is not needed for the core purpose, which shrinks the flow back toward what users expect. Sometimes the fix is separation, meaning you keep data collected in one context from being used in another context without clear boundaries, such as separating operational data from marketing data. Sometimes the fix is user control, meaning you create a meaningful choice that allows a person to opt in or opt out of the expanded use, and you ensure that choice is enforced across downstream systems. Sometimes the fix is transparency, meaning you change communication so the expected flow becomes accurate, but transparency alone is not enough if the flow is still inappropriate or overly broad. Contextual integrity helps you pick among these moves because it clarifies whether the main problem is unexpected sharing, inappropriate purpose expansion, or unclear conditions. Exam scenarios often hinge on choosing the most direct realignment step. It's also important to understand that contextual integrity is not the same as personal preference, because the goal is not to guess what a particular individual likes. Instead, it is about reasonable expectations shaped by social norms, the stated purpose of the service, and the cues users are given. A beginner pitfall is to treat privacy as purely subjective and assume any flow can be justified if some users might be okay with it. Contextual integrity pushes back by asking whether the flow is appropriate for the setting and whether the conditions of sharing are aligned with that setting's norms. In many contexts, like banking or healthcare, norms are strongly shaped by history and by sensitivity, so broad reuse for unrelated purposes is rarely seen as appropriate. In other contexts, like social networking, some sharing is expected, but even there, unexpected onward sharing to unknown parties can break integrity. This helps you reason about scenarios without needing to invent a user survey in your head. You anchor on context and plausibility, not on guesswork. Contextual integrity becomes especially valuable when a scenario involves secondary use, which is a common source of privacy risk and exam questions. Secondary use is when data collected for one purpose is later used for a different purpose, especially one the user did not anticipate. For example, a customer support chat might be collected to resolve issues, but then later mined to train models, evaluate employees, or build marketing profiles. Some of these uses might be defensible if they stay close to the original context and include proper safeguards, but others can feel like a context break if they materially change how the information is used. The practical task is to identify whether the new use is a natural extension of the original purpose or a leap into a different context with different norms. If it is a leap, integrity is at risk, and you should expect stronger constraints, clearer user control, or a redesign of data handling. The exam often tests your ability to recognize when a use is an extension versus a shift. Another place contextual integrity shines is in understanding role changes, because sometimes the data use stays similar, but the recipient role changes in a way that alters expectations. In a workplace context, an employee may expect a manager to see performance data, but not expect the same data to be sold to a broker or used by unrelated teams for profiling. In an education context, a student may expect a teacher to access coursework data, but not expect that data to be shared widely for commercial targeting. When recipient roles change, the transmission principle changes, even if the data itself stays the same, because different recipients have different purposes and powers. A beginner mistake is to focus only on the data type and ignore who gets it and why, but contextual integrity requires you to evaluate the whole flow. This is why third-party sharing often creates integrity problems, because the presence of a new recipient role changes the meaning of the context. Strong privacy operations treats role changes as triggers for review and user-facing updates. Time is another dimension that beginners often miss, yet it can strongly affect contextual integrity because expectations about how long data should persist vary by context. In a navigation app, users may accept location processing during a trip, but they may not expect indefinite retention of detailed location history if it is not needed for the service they chose. In a retail context, keeping purchase records for returns and receipts may feel normal, while keeping detailed clickstream data forever may feel excessive and surprising. When data lives longer than users expect, integrity can break even if the initial collection was understandable. That is why retention and deletion controls are not merely compliance chores. They are part of preserving the context's implied boundaries. A privacy technologist should ask whether the retention period fits the context and whether it is communicated in a way users can grasp. On the exam, answers that address retention, purpose, and downstream copies often demonstrate stronger contextual reasoning. Contextual integrity also helps you evaluate personalization and recommendation features, which are common in modern systems and easy to get wrong. Personalization can fit a context when it is clearly tied to the service the user is using, like recommending content within an app based on the user's viewing history. Integrity starts to break when personalization crosses into unexpected contexts, like using browsing behavior in one service to influence offers in a separate service the user did not connect mentally. Another integrity risk appears when personalization relies on sensitive inferences that users did not realize were being made, such as inferring health conditions, financial stress, or personal relationships. Even if the system never explicitly stores a sensitive label, the act of using inferred information can feel like a violation because it changes the meaning of what was collected. A practical privacy engineering move is to limit inference sensitivity, separate contexts, and provide meaningful control over personalization modes. The exam may test whether you recognize that inference can be a privacy risk even without direct disclosure. To apply contextual integrity under exam conditions, you need a calm method that works quickly while still being thoughtful. Start by describing the context in one sentence, focusing on the service purpose and the relationship between the user and the organization. Then name the key roles, including any third parties, and be explicit about who is sending and receiving the information. Next, identify the information type and whether it carries sensitivity through identifiability, intimacy, or potential harm. Then describe the transmission principle, which is the condition under which data flows, such as for a stated purpose, under user choice, with limited retention, or with restricted sharing. Finally, compare expected flow to actual flow as described in the scenario, and locate the mismatch that creates surprise or harm. Once you can name the mismatch, the best mitigation often becomes clearer because you can decide whether to reduce data, narrow sharing, strengthen control, clarify transparency, or redesign the feature. This method helps you choose answers that are grounded, not reactive. Contextual integrity is also a strong defense against the common exam trap of choosing a purely security-flavored answer when the core problem is appropriateness and expectation. Strong encryption and access control matter, but if the data use itself violates the context's norms, security does not restore trust. For example, securely sharing data with an advertising partner is still a context shift if users expected the data to stay within a service purpose and not be used for targeting. Another trap is choosing a purely policy-flavored answer when the system behavior needs to change, because writing a policy does not automatically enforce purpose limitation or preference signals across data flows. Contextual integrity pushes you to ask whether the proposed answer changes the flow in a way that restores an appropriate norm, or whether it simply adds documentation around a broken flow. The exam tends to reward answers that address root cause, and root cause in contextual integrity terms is often the mismatch between context and data flow conditions. This perspective helps you avoid selecting answers that sound impressive but fail to fix the integrity break. As you get more comfortable, you'll notice that contextual integrity connects naturally to other privacy engineering themes, which is part of why it matters for the CIPT exam. It connects to minimization because collecting less reduces the chance that flows will become inappropriate later. It connects to transparency because users can't form accurate expectations if communication is vague or buried. It connects to user control because meaningful choice is often the cleanest way to legitimize a flow that is optional rather than necessary. It connects to retention because time boundaries are a core part of what people assume in many contexts. It connects to third-party risk because adding recipients can shift the context even when the original use was reasonable. When you see these connections, scenarios stop feeling like separate topics and start feeling like one integrated decision space, which is exactly how exam questions are built. You are training a way of thinking, not collecting isolated definitions. When you can apply contextual integrity to real processing scenarios, you gain a reliable compass for deciding whether a data use is appropriate, not just whether it is possible or profitable. The best privacy technologists are often the ones who can look at a proposed feature and articulate, in plain language, why users would or would not expect a particular flow, and what change would preserve trust while still meeting legitimate needs. For the CIPT exam, that skill shows up as choosing answers that focus on aligning data flows with purpose, roles, conditions, and user expectations rather than reaching for one-size-fits-all controls. If you practice naming contexts, roles, data types, and transmission conditions, you can quickly locate the mismatch that causes privacy harm and propose a fix that restores integrity. That makes your reasoning consistent, which is what earns points when questions are worded in unfamiliar ways. Most importantly, it helps you design and operate systems where privacy is not an afterthought, but a natural fit with the context people believe they are in.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.